Welcome, my friends. In this video, we will continue working with the graphs of sine and cosine. Let's try this problem. We are asked to find the amplitude and period of y equals -3 times the sine of 4/3 x. Remember that the amplitude is the amount that the function oscillates either above or below its midline, which is typically the x-axis, unless you have a value for d. The amplitude can always be found by taking the absolute value of the coefficient of a multiplying the function. So that means in this case, the amplitude will be +3. This function will oscillate 3 units above and below its midline. Next, we are asked to find the period, which is the frequency with which the trig function repeats itself. The period can always be found by taking the period of the untransformed function, which is 2π in the case of sine, and dividing by the coefficient b multiplying x, which is 4/3 in this case. So in general, the period is 2π over b, and specifically for this problem, it will be 2π divided by 4/3. We can reciprocate the denominator and multiply to get 2π times 3/4. 2π times 3 is 6π, so we have 6π/4, which can be reduced to 3π/2. The period of this function is 3π/2, so every 3π/2 radians, this function will start to repeat itself. Let's try another problem. We are asked to find the amplitude, midline, period, and phase shift of this function. Let's start with the amplitude. The amplitude is always the absolute value of a, the value multiplying the function, which in this case is going to be 4. This function will oscillate 4 units above and below its midline. The midline relates to the value d that is either being added or subtracted from the function. Don't be confused here, we still have a value for d even though it's not in the proper spot in the general form of the transformed cosine function. D is this value right here, -2, that is being subtracted from the entire function. So that means our midline is at y is equal to -2. This entire function is shifted 2 units down. So that means that we will be oscillating 4 units above and below our midline of y equals -2. Next, we are asked to find the period and the phase shift. You may recall that when you have both a period change and a phase shift, you should factor out the coefficient on x before trying to identify the phase shift. So factoring out 2π, we will have -2 plus 4 times the cosine of 2π times x, and then we have to think about what would have to go here to factor correctly. Recall that factoring is just dividing out some value. In this case, we are dividing out 2π. So we can take 3π/2 and divide by 2π. 3π/2 divided by 2π is the same thing as 3π/2 times the reciprocal of 2π, which is 1/2π. The pi's will cancel, and we will just have 3 divided by 4. So that means that the value that we need on the inside of the function to factor correctly is just 3/4. You can check yourself to make sure that you factored correctly. 2π times 3/4 is equal to 6π/4. This reduces to 3π/2, which is exactly what we started with, verifying that we have factored correctly. At this point, we are ready to identify our phase shift. Since we have a value added on the inside of our function, that indicates a phase shift to the left. We represent that by -3/4. This is a phase shift of 3/4 units to the left, indicated by -3/4. Finally, we can find the period by taking 2π and dividing by the value multiplying x, which is just 2π. If we take 2π and we divide by b, which is just 2π, we will just get 1. So the period of this function is just 1. Let's try this problem. We are asked to write the function corresponding to the graph in the form y equals a times sine of bx, or y equals a times cosine of bx. Now the first thing I would do is identify if we have either a sine or cosine function, and if that function is either positive or negative. Recall that the untransformed sine function starts at 0, 0 and then increases from there. A negative sine function also starts at 0, 0, but decreases at the start of its period. A positive cosine function instead starts its period at 0, 1 and decreases from there. A negative cosine function starts its period at 0, -1 and then increases from there. So let's use this information to decide which type of function we have. If we look at x equals 0 on the graph, we can see that we decrease from there. That indicates that this is probably a negative sine function, because we start at 0, 0 and then decrease from there. We can also see that this function is oscillating between 3.5 all the way down to -3.5. That means that the amplitude is 3.5, which can be represented as 7/2 in fraction form. So that means our function looks like y equals -7/2 times sine of something. Let's try to identify the period of this function. How long does it take for this function to start repeating itself? Well, at the beginning of the period, we are at y equals 0 and decreasing from there. So when is the next time that this function is at 0 and decreasing? Well, that would be over here at 4 pi over 3. So that means the period must be 4 pi over 3. We know that we can typically find the period by taking 2 pi and dividing by b. We want to solve for b, which is the value multiplying x on the inside of our function. If we multiply both sides by b and divide both sides by the period, we will get a new formula. We can find the value b, which needs to be on the inside of our function, by taking 2 pi and dividing by the period. Since we know the period is 4 pi over 3, we can take 2 pi and divide by 4 pi over 3. If we reciprocate and multiply, we will get 2 pi times 3 over 4 pi. 2 pi times 3 is 6 pi, so we have 6 pi divided by 4 pi. The pi's cancel, and 6 over 4 can be reduced to 3 over 2. So that means that our value for b that must be multiplying x on the inside of our function is 3 over 2. That means that our completed function is y equals -7/2 times sine of 3/2 x. That is the equation of the function that we see in the graph. Let's try one final problem. We are asked to write the function corresponding to the graph in the form y equals a times sine of bx, or y equals a times cosine of bx. Just like last time, the first step will probably be to determine if we have either a positive or negative sine function or a positive or negative cosine function. Recall that a positive sine function starts at 0, 0 and increases from there. A negative sine function starts at 0, 0 and then decreases. A positive cosine function starts at its maximum, which is 0, 1 in the untransformed version, and then decreases from there. A negative cosine function, if it's not transformed, starts at 0, -1 and then increases. Of course, if you have an amplitude, then we won't start at 0, 1 or 0, -1, we'll start at some other place, but the x-coordinate will be at 0. In this case, it looks like we start at a maximum of 0, 3, and then we decrease from there. So the function that starts at a maximum and decreases is the positive cosine function, so that must be what we have. The amplitude is 3, because we start at a maximum of 3 and go all the way down to a minimum of -3, so we can say that the amplitude is +3. Therefore, the general form of our function is y equals 3 times cosine of something. Let's find the period to help us figure out what goes on the inside of the function. When does this function start repeating itself? Well, we start at a maximum of 3 and then decrease from there. So when is the next time that the function is doing the same thing? Well, that looks like it would be over here at 8. At 8, it looks like the function is back at a maximum of 3 and decreasing, just like it was at the beginning. So our period must be 8. Just like in the last problem, we can solve for b, which is the value that must be multiplying x on the inside of the function, by taking 2 pi and dividing by the period. b is equal to 2 pi divided by 8, which simplifies to pi over 4. That means that our completed function is y equals 3 times the cosine of pi over 4 times x. That is the function that represents this graph. Alright my friends, that finishes this video practicing with the transformations of sine and cosine.